The diameters of ball bearings produced at a factory are approximately normally distributed. Suppose the mean diameter is 1.002 centimeters and the standard deviation is 0.006 centimeters. What proportion of ball bearings can be expected to have a diameter under 1.020 centimeters? So again, let's draw on our picture here. We have our mean, and then we're talking about under, so just a value here, everything under that here. So we're looking for the probability that x is less than 1.020. So we're going to use normal CDF, and our lower bound is negative 1e99. Our upper bound is 1.020. Our mean is 1.002, and our standard deviation is 0.006. So let's type that in and see what we get. So second vars 2, negative 1, second comma will give us the e, 99, comma 1.020, comma 1.002, comma 0.006, close parenthesis, enter. So we get 0.9987 there. It's a pretty large proportion there. So the next part, we want to know a diameter over that value. So we just calculated under, so let's do the complement here. So we want, over. So let's do 0.9987. So 1 minus 0.9987, and we get 0.0013. The next one, what proportion of ball bearings can be expected to have a diameter between 0.980 and 1.020? That is, what proportion of ball bearings can be expected to meet the specifications? So we want to know, we have our curve. O to O and 0.980, so we want in between here. So in between there. So we want the probability that x is between those values. So we're going to do normal CDF. And our lower bound is going to be 0.980, and our upper bound is going to be 1.020. Our mean is 1.002, and our standard deviation is 0.006. So let's calculate that and see what we get. So second vars 2, 0.980, comma 1.020, comma 1.002, comma 0.006, close our parenthesis and enter, and we get 0.9985. So approximately 99.85% of the ball bearings meet our specifications there, so that's good. So now we want to know what's the probability that the diameter for a randomly selected ball bearing will be over 1 centimeter. Again, rough sketch here. So our mean is 1.002, and we want it over 1. Move this over here. So the probability that x is greater than 1. So we're going to do normal CDF. And 1, 1E, none. Our mean of 1.002, standard deviation of 0.006, and let's see what we get. So second vars 2, 1, 1, E, E, comma 1.002, comma 0.006, close our parenthesis and enter. So 0.6306. So the probability there is 0.6306. So the next part here we have is what is the probability the diameter will be under 0.995. So again, rough sketch to help us out there. Our mean, and then under 0.995. So the area to the left this time. The probability that x is less than 0.995. So we're going to do normal CDF negative 1E 99, comma 0.995, comma the mean, which is 1.002, comma our standard deviation sigma, which is 0.006. And let's see what we get here. So second vars 2, negative 1, second E, second comma, which gives us the E, 99, comma 0.995, comma 1.002, comma 0.006. And we get 0.1217 there. Our next part, we want to know what is the percentile rank of a ball bearing that has a diameter of 0.991 centimeters. So again, when we're looking for the percentile rank, we're looking for the probability that x is less than or equal to that value. So this one is going to be normal CDF, and less than, so our lower bound is going to be negative 1E 99, upper bound is going to be 0.991, our mean of 1.002, and standard deviation of 0.006. Let's type that in. So second vars 2, negative 1 second, comma, which gives us the E, 99, comma 0.991, comma 1.002, comma 0.006, close parenthesis, enter, and we get approximately 0.0334 there. So we want to convert that to a percent. So on the calculator, I can just press times 100, or we can move the decimal place twice. So this is approximately 3%. So this is the third percentile. So now we want to know the percentile rank of a ball bearing that has a diameter of 1.011. So same idea. So the probability that x is less than or equal to 1.011. Do the same thing. So normal CDF. So negative 1E99, comma 1.011, comma 1.002, comma 0.006. Let's put that in here. So I'm going to do second, enter, second, enter. So that'll pull back what we typed in for the last problem, the normal CDF. I'm going to go up and then go over to where it says 0.991 and change that to 1.011 and then press enter. So here we get roughly 0.9332, and again I can multiply by 100, so that's roughly 93%. So this is the 93rd percentile. Oops. So our next part here is the 10th percentile of the ball bearing. So this time we have to find the value. So we're going to use inverse norm this time. We're going to find the data value. So we know that this is 0.1 and we want to know what x equals. So x is going to be equal to the inverse norm of 0.10, so that's our area to the left. Inverse norm always uses the area to the left. If you have a calculator menu, it's just going to say area, but remember that's the area to the left there. And then our mean and our standard deviation. So let's type that in and see what we get. So second vars 3, 0.10, comma 1.002, comma 0.006, close parenthesis, enter, and we're going to round to 3 decimal places since that's what everything is in terms of. We get 0.994. So the 10th percentile of the diameters of ball bearings is 0.994 centimeters. Our next part here is we want to determine the diameters of ball bearings that make up the middle 99% of all diameters. So again, let's draw a picture out here. So we have, 99 in the middle, so 0.99. So let's do 0.99, well actually 1 minus 0.99, that's what's left over, divided by 2, and that's going to give us what's left in the tail. So this is 0.005 on the left tail and 0.005 on the right tail. We're looking for x1 and x2. So the left and right hand values, let's kind of split that up into those 3 portions. So x1 we can find by doing inverse norm of 0.005, comma 1.002 our mean, and then our standard deviation of 0.006. Again, let's round to 3, so we'll do second vars 3, 0.005, comma, the mean, which is 1.002, comma, our standard deviation sigma, which is 0.006, and we get approximately 0.987. So to find x2, we're going to do inverse norm, draw this below, and the area to the left of this, we need to add the 0.99 and 0.005. So this is going to be 0.005 plus 0.99, comma 1.002, comma 0.006. So let's do that. So second vars 3, 0.005, comma 1.002, comma 0.006. So 0.005 plus 0.99, 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 comma 1.002, comma 0.006. 0.005